Okay, morning everyone. Welcome to this session number 351. And today I will continue with the problem that yesterday I was attending. It's related with this. And the problem is this basically is search and sum the cousin, the cousin of the every node, yeah, and that's it. Now here I have the though because let me show you. I have this, and basically this is an error, the typical error that I am out of the I am trying to access an position that doesn't exist. Yeah, for example, if the size of the array is 1 and I am trying to access to the index 1, don't make sense because we start in 0. Yeah. But well, in this case I am getting this error. And I think that is because when you start here, for example, the first element, the size is 1, and in this case, okay, this is equal 0, meanwhile 0 is minor to 1, yeah. Remove the first element. Okay, in this moment, the queue is empty. The queue is empty. Now, for example, okay, it's not execute this and add this. Okay, now we are here, the 4. We remove the 4 and we still having the 9. Okay, and in this case the queue is empty now because contain at least one element. The size it's equal to yeah, because this start in 0. Plus 1 the next. Why? Okay. Okay, and okay, what is happening here? The book. Yeah, it's with this problem. Okay, it's the first time. Now go to this, is ignore. Now the next step is this. Here we have the 4. In this case, the 4 and the 9. We have 2 elements. Even why appears the 0 here? Q. Okay. Again. The first time we have the root and we have the Q. The Q is basically parent and child. do anything. And now is the next. The next basically is, this is the parent and the child. We are saying that the 4 the parent of this 4 is the 0 that was updated previously, that this, and we are saying that the 9 have the same parent. Yeah, now okay, we are here, and now we remove the first element. Now the first element is basically this. We are saying the parent is a 0 and the value is 9, and we have another thing here, another node here. Now the next that is x, no, I, it's 0 and the size is 2. The size is 2. Why? Okay, the problem is here. The first time don't do anything. Now the next time, okay, here, I it's equal 0. Here is less I. Yeah, this is because the size of the teeth change in this point. I think I can update this by q.size, you know? Yeah, in this way I can avoid this problem with the exception, but now is 007 1. Why? I think that I am losing the values. Result in index I, okay. What is happening here? 0007, and in the next okay, the first time, okay, now here we are in this, in the 4, right? No, in the result 0 and 0. We have the Q 0 1 10 1. I reached this. No. Okay, we are here 5 blah blah blah. We start. We are in the top, right? Now the next that is move to this and this 4 and 9. Okay, for the 4, why don't I think that is the debug is have a problem. Let me check here, because should be start here. This is the 4 should be, why not? Because it's 0. Yeah, makes sense. Okay, yeah, because it's 0 and 0 not make sense, because basically it's up, don't have more elements. But for the next, here we have 1, 10 and 7. In this case the key only have this because the first was removed, and this this is the 1, and the 4, this 4, and the 10 and the 7 is here. 10 and 7. Okay, now is basically search over these elements. And okay, now a right temp should we have the 10. Well, in this case appear why appear with different number? Because here appear no, this is wrong, because yeah, this basically should be have like this. Oh, come on, because I am sorry, this was wrong, and we only start to 0 to the final because I am removing the element. I don't need calculate anything. It's only a simple transversal, you know. Let me restart this. Now here I'm starting here, x minor. This is not possible, don't make sense. X, okay, well, this doesn't matter, but this y is 27, 8, 0. The first is y20. Because it's add this plus this, but that makes sense. Let me check what is happening. Okay, we start with the first element, that is the 5, that is the root. Now is basically remove, and in this case don't execute anything, the result is 0. Okay, next. The next is the 4. We have the 4 and the 4 and then in the 9, and remove the first, that is the 4. The q is equal 1, and here is, this should be at least greater than 1. What? Okay, we start with the 5. The 5 is ignored. Now the next step is the 4 and 9. The queue contains two elements, the 4 and 9. Remove the first, we only have 1 in the queue. Now integer x is equal to 0, meanwhile x is minor to q. 0 is minor to 1, yeah. If q is greater, the size is greater than 2. In this case, it's not. No, this is wrong. Well, for example, here is calculate the current yeah, I am calculating the same no, yeah, at least one. Here I need avoid that the array temp should be different to the array. Why? Because could be happen in this case that where this is trying to validate this itself. Why appear? No. Let me check the book. What is happening here? The first time is ignored, the second time is ignored. Yeah, here. Now we have that the current is a 4. And this should be have the 9. The 9. Now have the same parent. Yeah, have the same. Yeah, means that exactly. Now the next that is the 9. No, it's not execute more. Why is execute? Q, what have Q have 1? Yeah, it's because previously I add this, no, less size. No, this is wrong. My problem is here. Yeah, my problem is here. We start here, it's okay. Now the next stat is 4 and 9. I think that create another size like this, and every time that I remove this is basically this. Yeah, and here is with this. Okay, well, at least works. Now what is happening with this 8? Why this appear as a 0? We start with this is the first. Now this is the 4. Okay, we have the 4, that is the parent, and this is the other element, that is the 9. This will be performance, but aren't causing. Now the next that is the 9, and the s is equal 1. Should we execute? No, shouldn't execute. Is 0 0. Okay, got it. Now the next that is the 1, the 10, and the 7. I remove the 1. Let me check the size. The size is 3. Because we have 3 elements. Got it. Now here is the parent basically is the 4. That contain this and this, and we are asking this and this are causing. In this case, can be. This should be have as a false. Parent temp and array temp, no, and parent are the same. Now the next is 1 with 7. Yeah, in this case, the parent temp is this, and the parent of the other are different. Yeah, means that this is the problem, the index, because I am in the right, the I is right, but the X no, because in this case X start in 0, but this should we have like this. No, I know if for this, sorry, this is X. If X always start in 0, who know the position of the other element. I is the first. I know that it's I plus X plus 1. Yeah. My gosh. Okay, now it's time to another case. Okay. Now the next set is this. Okay, it's a good thing. My gosh. Now here is this. Okay. Let me use this. Okay. I think that I did it. Please. Okay. I think that it's enough. Okay, very bad performance, but I can do it. Okay. Now let me check. Okay, now the first is here. Okay, I know that it's not the best solution, but at least I resolved, and I will check another possible answer of this. This and solution using BFS Java. Yeah, and in this case post. This is the link. And okay, and okay. Now let me think another way to solve this problem. Yesterday Joe mentioned that a double DVS, but how? Because with the DVS, maybe saving the positions in a map. I'm not sure. We start with this and we go to yeah, because for example in this case, let me move a little bit here. In this case, okay, here for example, I can assume that, do you imagine that have more elements, for example 7, and here is 11, 20, yeah, that's it, and yeah, another 30. Now here for example, I can assume that of the t's the elements of the every node can be cousin because have the same parent. Yeah, in this case it's only, okay, please return the values of these elements, only will have 2. In this case is 0 and 0. Okay, come back to this. And we have that of the t's, we have 0 and 0, and now of the t size is 0 and 0. The sum of these are 0, no. For example, the sum of the cousin go to this, go to this, go to this. In this case, no, but in this case, I need transversal again to know these elements. No, let me check what is the answer. To pass BFS. Okay, let me check. Okay, for example, here use a Q. I think in my case, this is the heavy the operation that it's heavy, yeah. But for this reason, my performance is very bad. I think it's for this reason because I am transversal the every level, yeah. But in this solution, first BFS calculates not on each level. I think that this is more heavy than my solution because in this case, transversal twice the binary tree, and in my case, okay, let me check here. If yes, the zooms. Level zooms, it's an integer. I don't know. I think that this is more expensive. To pass TFS. Okay. This is using TFS. We have this. Replace is the function. What is the original? Replace value in tree. In tree intern is this. Receive the node, calculate zoom, and replace value information in the root. Calculate the zoom level in the level. It's that left, right. Level zoom in the index level, that in this case is 0 the first time, plus equal node, and here it's increasing 1. Okay, basically is increase this. Now here is nodes, sibling zoom. What is sibling zoom? Left child. Right child. And let me check this. For example, here is the calculus zoom. Okay. Okay, we have that. We create an array of 10,000. Why 10,000 is the maximum value? Is for this. Okay, got it. Now this basically, this is the number of nodes. Okay, now we replace calculate the sum. Okay, the first function is basically this, and in this case the first node that receive is the 5. It's not null. Level sum in the level, in this case the level is 0 here. It's equal node dot val, in this case is 5. Yeah, and next to is calculate the sum node left, in this case go to this side, and again is null, no, the level is 1. Here is 4, and now again go to this side. Let me remove this, and the level is 1. And now when it's complete, go to the right, don't have nothing, left and right don't have nothing. Now come back to this. Now go to the right side, it's null, no, level in the position here is plus equal, no, this case this start in 0, and we are saying in the index 0 is plus value. Go to the left, increasing 1. Now have 1 level in the index 1, it's equal the value, and go to the left, that is 2 here. Now in this case is null, no, okay, level in the index 2, it's equal the value, that is 1. Go to the left, don't have the nothing, go to the right, don't have the nothing, come back to this. Here is complete. Now it's time to this, and not to right, in the index 2, this level sum plus equal the value, in this case is 11. 10 plus 1 even is yeah. Go to the left, go to the right, don't happen nothing because it doesn't exist. Come back to this, come back to this, and go to this side. In this case this is 1. Now in the position 1 plus equal the current value, that is 9. Here is 4 plus 9. Okay, and now go to the left, don't happen nothing, go to the right with the value of 2, in this case is 7 in the index 2, here plus 7, and go to the left, go to the right, and that's it. Okay, and the final we have this array with only 3 values, 5, 30, and 18. Yeah. Now the next that is this. Now here is replace value in the tree internal root, and that is this. Receive the node, and in this case the node is this. Is this sibling Zoom. What is the meaning of sibling? Sibling. Each of two or more children. Okay. Now we have here. Oh. Okay, the label, this is 0, 0, and the node is a 5. That is this. Now the node is null, no. Left child it's equal, not to left, that in this case is 5, the left is 4, and the right is 9. And the left it's here is 4, it's equal null, no sir, means that I return 0. And the right is null, no. Means that return 0 too. Hey yo, what's up? I am trying to check what is the other solution of the problem that yesterday I resolved with VFS with my idea that I had yesterday, but I have a very horrible performance. I am using too much, or it's slow, because in memory I am not bad, but with the runtime is very slow, and basically is following this idea of the BFS, but it's slow. I'm trying to check the solution that proposed the leetcode, and that is what is this is the solution that proposed leetcode, and I am here. Okay, now in this point basically it's left it's 0, right it's 0, label is 0 or 1. Okay, this basically is for contemplate that the first 3 elements all the time in the trees, the first 3 elements are zeros. In this case, change to 0, 0, and 0. And now for the next, in this case, where is this? No. But I am using DFS here. Sorry. Here, this the first time is 0. And go to the left. This with the right child val. In this case is 4, 0, 1. Here receive this 4, 0, and 1. And now it's equal the 4 have the left child is null, no. In this case is 0, the right is 0 too, the label is this is transformed to 0. It's ignore completely the values, and now go again to this. Now the left, well, this start with 1, with 0, and with 2. Now go to this. In this case is null, no. Okay, the left is null, means that I need to take the current value. No, dot left is equal null. No, I see my error. My error is that I am confusing this, the conditional. I am taking the positive value. Here, for example, the first time we start here, the 5 is equal null. No, in this case, where have child in the left. Basically, you take the value. In this case, is 4. Now it's 9. Basically, it's this and this. And is the label 0? Change to 0. And replacement here is the node that is 4. with 4, with 1. Yeah. Okay, now here is 4, 4, and 1. Now here I start again. Left child, half left child. Yeah, the left is basically 1. Here is 10. The label is 1, means that automatically change to 0 and go to this, the left, 1, 10, and 2. Yeah, now here is 1, 10, and 2. Now go to this side again. This is null, no. Have left child, no, because it's the leaf. It's 0, 0. The label is this, no. Okay, it's this, label sum. Label sum in the index 2, 0, 1, 2, that is 18, less the current node, 1, less sibling sum, that is 10. In this case is 7. Yeah, and I put the 7 here. And go to the left, go to the right, don't have the nothing because don't have more elements. Now continue, come back to this and continue with the next. In the next is basically the 10, this have 10. And it's not, this is 0 because don't have more elements. The 10 don't have more elements. Now it's this, here is the label sum in the, this is 18 because never is modifier. Is 18 less 10 less 2, it's equal less 2. This is 6. Not dot value is 10. Less sibling. Sibling needs to be 0, 1, and here receive the 2. One, 2. Why? I'm doing something wrong here. The node that start here is the 10. The sibling nums is the second, means that the right child I think that is this is 9. Here receive the 9. And here receive the label is 2. Now when reach this point is 18 less the value of node that is 10 less sibling that is 9. No. What is wrong? What is wrong here? Setting 0 with this. Now the node of the this is which node is 4. Now go to the left. Four, 4, and 1. 4. why. Okay, I will do again. Okay, this is the results. Now we start here. 14 received the node of 5, the sibling 0, level 0 is not, here is the 4, 9 is the, this change to 0, and go to the left. In this case, with the left, receive the 9, basically this is put here. The node is 4, and the level is 1. Yeah, now start here. Note that this 4 is null. No, siblings is 9, and this is 0, is 1. Now the left is basically this element have the left and right element. Yeah, here is 1 and here is 10. Okay, now is this? Yeah, this change to 0, and go to the left, in this case with the value of 1. The right child in this case is 10, and the level is 1. Now go to this, is null, no. In this case the leaf means that this is 0 and 0. Now here the level sum in the level 2 is 18, less the current node that is 1, less the sibling is 10. Yeah, because it's the right. And in this case is 7. Now here is 7, and it's complete because it's a leaf and it's only return. Come back to this, and now in this side, in this moment, sorry, four, 9. Now this receive this received the 7. No, the 7 no. If I am here, if this is the node, the left it's 7 and the right is 10. Means that this receive 10, 10 and 2. Now go to this, and this is 0, 0, is 18, less val that is 10, less sibling that is 10. No. This is the level 2, the node dot val is 10. Less sorry, this is not 2, the value is 18. Okay, I think that this value should be passed here. In this case the left child starting here is this, is the 1. For this reason when receive this, and now, okay, now is 7. Okay. Yeah. In this case, in essential is that calculate the first time the sum of the positions. In this case, the first doesn't matter, but well, in this case is 5. Now for this level is 13. You see, Now for the next, that is 18, that is basically this, and even let me put here, is 18, is 13, and this is 5, and basically for this level and this level are completely ignored and put 0, 0, and 0. But for the next, basically is that, okay, we know that the current sum for the foul, so you can imagine that we have this, and now is when I go to this side, I pass the, I don't know how to say that, but the brother node, yeah, and basically here is this value less the current value less the brother. In this case is 7, yeah, and this is the same idea here. We have the maximum less the current value less the brother, yeah, because we, yeah, makes sense because if we are searching the cousin values, like for example, if you have this, no, yeah, something like this, yeah, and you imagine that this is connected with other, and this is with other, and blah blah blah, yeah, basically makes sense that this only need, if you know that the sum of here is 100, makes sense that remove the current value because it's part of the total, yeah, is total less current less his brother. Why? Because I don't feel worried. It's more yeah, it's more, well, it's cheaper only reduce or remove the brother that validate all the others node that I know that are cousin for the foul. The only case where the node is not a cousin is where is a brother. Means that where is this? Yeah. I like it. I like this for this reason. In my case, for example, I have this error. I am validate all the cousins instead only valid the brother, you know, where is brother, basically apply this operation and change. And for the foul, all the other elements have the right value. But well, wow, it's a new idea that I have now. But well, it's enough for today. Thanks for following this transmission, and I hope see you in the next. But well, bye bye.